Hello, my name is Brian Moda, and I will be doing problem number 6. So, problem number 6 states that a closed rigid tank whose volume is 1.5 meters cubed contains refrigerant 134A, initially a two-phase liquid vapor mixture at 10 degrees Celsius. The refrigerant is heated to a final state where temperature is 50 degrees Celsius and a quality of 100%. Locate the initial and final states, sketch of the T versus V diagram, determine the mass of vapor present in the initial and final states, each in kilograms. So things to pay attention is that it states it's a rigid tank, so the volume at 10 degrees Celsius and 50 degrees Celsius will remain the same because no heat will get in or outside of the tank. And also, thing to know is that at 50 degrees Celsius, the quality is 100%. So that means that it's going to be a saturated vapor. So I drew the graph, and this is the T versus V graph. And at 50 degrees, it lies at the line because it's purely 100% saturated vapor, and you go at the same you go down, and then at 10 degrees Celsius you would have liquid and saturated vapor. You have both. So to solve this at 10 degrees Celsius, we want to find the specific volume of saturated liquid and the specific volume of saturated vapor. So to start this off, we're gonna start off with looking at the VF, which is the specific volume of the saturated liquid. You come to table A10 and you look up the properties, and you will find out that at 10 degrees Celsius, it lies in between here, so we have to figure that out. So we can, since it lies exactly in between, we can just take the average and we can get the numbers. So 7.91 plus 0.7884 divided by 2. This is taking the average, and you would get 0.79275 times 10 to the negative 3 meters per kilogram. We get to the negative 3 because the graph states that if the VF is times 10 to the 3, so that's why we have that. So to find the specific volume of saturated vapor, which is VG, we will look at the table again, and it's going to lie in between those 2 points. So we're just going to take the average, which is 0.0460 plus 0.0525 divided by 2. We would get 0.04925 meters cubed to the negative, times 10 to the negative 3 meters per kilogram, meters cubed. Sorry. So to jump ahead, we're gonna at 50 degrees Celsius. We know that it's just purely saturated vapor, so we're just gonna find the specific volume of saturated vapor, which will be, for this one, I'm gonna use interpolation, which is basically the same thing as doing the top, but just to show how that works. It's the specific volume at 50 minus V48 over V52, V48. So I got these because the temperature at 2 is 50 degrees, and you look at the table A10 again, but you look at 48 degrees, 52, it's gonna lie in between. So we're gonna use this one, VG, which is just for the saturated vapor. It's gonna lie in between there. So this equals the temperature, so 50 degrees Celsius minus 48 over 52 minus 48. I need to plug that in, so V50 0.0159, 0.0142 minus 0.0159 equals 50. 48 over 52 minus 48. We solve that, so Vg at 50 degrees Celsius, we're gonna get 0.01505 meters cubed per kilogram. So with this information, we can find the mass at final state 50 degrees Celsius. So the mass at 50 degrees Celsius will be, so I'm gonna do mass final equals the volume of the rigid tank over the specific volume of the saturated vapor. Specific SV, specific volume. So the mass final, we're gonna get 1.5, which is given, meters cubed over 0.01505 meters cubed over kilograms. So the meters cubed cancel out, and I get a mass of 99.66 kilograms. So this is the mass of the vapor at the 50 degrees. So at 50 degrees, this is my mass final. This is of just the saturated vapor. So now I'm gonna utilize the quality. So with this equation, I will use up here. So with the equation V, so I'm gonna do V initial equals V final plus X over VG. Oh no, this is not final. This is the specific heat of saturated liquid. So it's that minus the V saturated. So here I manipulate and I'm gonna get the quality. So sorry, I'm solving for at 10 degrees Celsius, my quality. So my quality is that over my V minus VF over VG minus VF. So I'm gonna plug in my numbers. So my this one, I get it from here. So I'm using this value into there. So I'm gonna get 0.01505 minus 0.79275 times 10 to the negative third over 0.04925 minus 0.79275 times 10 to the negative third. So plug that in the calculator, you solve. My quality is 0.2945 at 10 degrees. So knowing our quality, we know our mass total is gonna equal the mass initial. So the mass total is here, it's gonna equal mass here because the volume is gonna stay the same throughout the system. But we know that at this point we have a saturated liquid and a saturated vapor. So we just want to find the vapor. So knowing the quality of that, we're gonna use our mass of the temperature at 10 degrees Celsius equals the quality times the mass total, which my mass at 10 degrees Celsius is going to equal 0.2945 times the mass total, which is 99.667. Plug that in the calculator, you get 29.302 kilograms. So this is my 10 mass at 10 degrees Celsius. So you get that at 10 degrees Celsius, that's the vapor, mass of the vapor, and then at 50 degrees, that's the mass of the vapor. And that's how you find it. Thank you.